Okay, Chapter 8, Day 3. What we're going to look at today is another piece of the puzzle of this whole linear regression chapter. And today it's about the coefficient of determination, symbolized by r squared, either lowercase or uppercase, r squared. Not called r2, it is r squared. So the coefficient of determination is this. It is the percent of variation in the y variable that can be explained by the variation in the x variable. Okay? So it is the percent of variation in the y variable that can be explained by the variation in the x variable. I know that sounds like, what? I'll use it in a sentence here with a problem that we've been doing in a second. So, it can also be stated, and this isn't used too often, but sometimes you might see this on the AP exam. It might talk about the percent of variation in the y variable that can be explained by the regression line of x versus y. This one you'll see less often. Sometimes you might see it in a multiple choice question. This one is the one that we will write on our paper. So let's use this. So do you remember we were doing the problem with temperature and coral growth? So what do we have? We have an r squared of 0.78. If you remember, r was equal to negative 0.88, I believe. Let's check my calculator here real quick. Yep, negative 0.88 was the r value. So r squared was 0.78. So, what does that mean then? Well, if I follow this template, 78% of the variation in my y variable here is coral growth. Can be explained by the variation or variability in temperature. So 78% of the variability in coral growth can be explained by the variability in temperature. So that's how you write it. But what does that really mean again? So what does that really tell us? Well, we have data in which we've looked at temperatures and coral growth. And does temperature seem to impact it? Yeah. As temperature went up, coral growth went down. Okay? For every 1 degree temperature, we lost coral. And as a predictor, this really is pretty good. 78% of the change that we see in the growth can be explained by the changes that we see in temperature. There's other factors, 12% or 22% come into play somewhere else, but 78% of that change in the coral growth seems to be explained by the changes that we see in temperature. So how much does temperature impact coral growth? Quite a bit. 78% of the change that we see in growth seems to be explained by the change in temperature. And that's what r squared tells us, and that's how we use it for a measurement of how strong one variable seemed to have an influence in the other. Now, again, it's not a cause and effect relationship because we don't have a controlled experiment. I could probably run a controlled experiment on temperature and coral growth, but from our linear regression model, 78% of the variability in coral growth seems to be explained by the variability in temperature. So, a couple things to note as we go through this. R squared gives us a feel for how strong of a predictor our equation is. 78 is pretty good, 0.78. It came from a 0.88 correlation. But you have something to keep in mind. If I take r and square it, I get r squared. And you're saying like, duh, but you have to keep this in mind. So if I give you r, you can get r squared. If I give you r squared, you can take the square root to get r. But here's the problem. As you can see in this question, if I take the square root of 0.788 or 78, I get 0.88. But this was negative, because if I take this negative value and square it, I get 0.78. So because of that, and because of what you learned early on in algebra, you have to be careful. Since the square root of r squared will always be positive, you need to check the scatter plot or the equation to see if r truly is negative. Because the square root of r really is plus or minus. Square root of r squared really is plus or minus r. But on your calculator, it'll always be positive. You take any number, take the square root of it, it'll be positive. So, check your equation. Here's an equation I had from the past from a different scenario. And you can see if the slope is negative, it'll lead to negative correlation. Or if you look at the trend of the data, if the trend is negative, it leads to negative correlation. So, sometimes on your test it will say, here's r squared, tell me what r is. Don't just blindly take the square root of it. Take the square root, look at the data, or look at the equation and determine whether this has to be positive or negative. So that's r squared.